Welcome to this lesson on rate problems. Please make sure you have these notes in front of you so we can begin our lesson. The learning objective for this lesson says, I can use rate reasoning to solve problems. So for problem 1, it says the table shows the fees at a parking lot. First hour is free. The second hour is $1.25. After the second hour, the cost is $2.50 per hour. Ben parked his car there from 9 a.m. to 2 p.m. on the same day. How much did he pay for parking? First thing I want to do is I want to figure out how long Ben was there to park his car. And it says he was there from 9 a.m. to 2 p.m. So from 9 a.m. to 2 p.m., that's a total of 5 hours total. Now let's figure out the price. So parking for the first hour costs nothing. Parking for the second hour costs $1.75. For the last 3 hours is going to cost him $2.50 times 3, which is a total of $7.50. So to figure his total cost, we would add $1.75 plus $7.50, and that gets us to a total of $9.25. So Ben paid $9.25 for parking from 9 a.m. to 2 p.m. on the same day. So for example 2, it says Andy needs new batteries for his new video game controller. He is trying to decide between 2 brands. A package of 2 brand A batteries costs $3.20. The manufacturer claims that the batteries will last for 20 hours. A package of brand B batteries costs $2.80. The manufacturer claims that the batteries will last for 14 hours. Which battery should Andy buy? And explain why you think so. So the first thing I want to do is I want to break this off into 2 different steps. I'm going to compare brand A first, and then I'm going to compare brand B second. All right, so let's go back to brand A, and we know the cost over the time would be $3.20 per 20 hours. So if I want to figure out the unit rate per hour, I would divide my fraction by 20, top and bottom, to get my unit rate of 1 hour, because 20 divided by 20 is 1, so that's how I got my denominator. And to get my dollar amount, I would do $3.20 divided by 20, and if I do the in and out, this would be in, this would be the out, I get 16 cents. So brand A says I would pay 16 cents per hour for those batteries. Let's go ahead and do the cost analysis for brand B. Brand B has our money over our time, and the amount of money we have is $2.80 over 14 hours. So if I want to find the unit rate, I would divide by 14 on the top and the bottom, because that gets my bottom number to be 1. So I get 1 hour, because 14 divided by 14 gets 1 hour. And if I do $2.80, this would be my in, and 14 would be my out, I would get 20 cents. So by comparing brand A and brand B, brand A is 16 cents, and that's less than brand B, which is 20 cents. So brand A would be cheaper because it cost less for 1 hour. For example 3, it says Mr. Anthony drives his truck at a speed of 45 kilometers per hour. Now, in a past lesson, we talked about the word per, and anytime you see the word per, we know that this would be a rate. So 45 kilometers per hour is the rate. That is how far or how fast Mr. Anthony's truck is going. Let's go ahead and use this diagram. I'm going to draw a triangle, and inside the triangle, I'm going to put D on the top, and the D stands for distance. I would put R down here, and the R stands for rate, or how fast something's going. I would put T down here, and the T stands for time. So we can generate a rate equation using this diagram. I'm going to put a multiplication sign down here between the R and the T, and I'm going to put a division sign either on the side of the D and the R, or a division sign of the side that says the D and the T. So here's one equation that we can write. We can say the rate times the time will get us our distance, or we can say the distance, notice how the distance is on the top of the triangle, divided by our rate will get us our time, or we can say distance divided by our time will get us the rate. So we can use these equations to solve rate problems. So let's go ahead and continue with example 3. For part A, it says at this speed, now remember the speed that we talked about was the speed of 45 kilometers per hour. How far does he travel in 2 hours? So I'm going to take my diagram again. And they do not tell us our distance, so I'm going to call distance D up here. They do tell us the speed. The speed is 45 kilometers per hour. And they do tell us the time. It says in 2 hours. So I'm going to multiply the distance and the time. I'm sorry, the rate and the time. So rate times time to get me my distance. And the rate is going 45 kilometers per hour. Times it by 2, because that's 2 hours. When I multiply that, I get 90 kilometers. So for part B, it says at this speed, once again, we're using the same 45 kilometers per hour speed. How far does he travel in 5 hours? So let's go ahead and draw that diagram again. We don't know the distance. I'm going to call it the DD. We do know the speed, which is 45 kilometers per hour. And we know a new time, which is 5 hours. So I'm going to say the rate times time is equal to the distance. So my rate is 45 kilometers per hour, times it by 5 hours, and my distance would be 225 kilometers. For example 4, it says Lucas ran around a field at a speed of 8 meters per second. How long did he take to run a distance of 96 meters? So when I look at this problem, once again, I see the rate, which is 8 meters per second. And I know this is the rate because I see the word per. And they're asking me how long did it take him to run the distance of 96 meters. So they're giving me a distance. And they're asking me to find the time because it says how long. So that is the unknown, the time. So I'm going to use that triangle once again. The triangle was distance on the top, rate, and time. So let me go ahead and plug in some values here. I do know the distance, which is 96 meters. I know the rate, which is 8 meters per second. And I don't know the time, so I'm going to call that t. So one equation that we can write is distance divided by rate. So I can put a division sign here. Will get us our time. So our distance in the problem was 96 meters. We're going to divide that by 8 meters per second. And that's going to get us our time. So 96 divided by 8 will get us 12 seconds. So Lucas can run 96 meters going at a rate of 8 meters per second in 12 seconds. For example 5, it says post A and post B are 9 meters apart. Post B and post C are 21 meters apart. A bicycle travels from post A to post B in 2 seconds. Then it travels from post B to post C in 3 seconds. Find the average speed of the bicycle from the distance of post A to post C. So we know that the distance from post A to post C, and we do know that they traveled at different rates. So they're not traveling at a consistent rate. So let's go ahead and draw this diagram. I'm going to list post A right here. I'm going to list post B right here. I'm going to list post C right here. So I know from post A to post B that the bicycle traveled 9 meters per 2 seconds. And I also know to go from post B to post, by the way, that's a post C, post B to post C, this was 21 meters per 3 seconds. So to calculate the average speed, let's go ahead and use this formula of the total distance that we're traveling over the total time that we're traveling. So to find this information, the total distance would be from post A to post B, we know that was 9 meters. Plus, from post B to post C, we know that was 21 meters. So that total distance that the bicycle traveled was 30 meters total. Now we're going to have to figure out the total time. The total time to travel that 9 meters was 2 seconds, and the total time to travel the 21 meters was 3 seconds. So the total time was 5 seconds. So let's go ahead and plug this information into our formula. 30 is our total distance over 5, which is our total time. And our average speed is 6 meters per second. And that's traveling from post A to post C. So now that you've completed this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this lesson that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.